Solve the system using row operations. Here we have a system of 3 equations and 3 unknowns. And if we use row operations, then our first step is to write the system as an augmented matrix. So let's do that first. Here we pull our coefficients out of the system, our coefficients of x, y, z, and then our number terms over here on the right-hand side of that matrix. So that first equation in coefficient form is a 1, 3, 2, 11. Second equation, 3, 7, 4, 23. Third equation is a 5, 3, -5, and a -14. Now, we want to use our row operations to get 1s on the diagonal and 0s below those 1s. And we do this column by column. Our first column, in this, we want a 1 in this diagonal location. We do have a 1 there. We want 0s below it. So our next matrix, in it, let's just rewrite that first line, 1, 3, 2, and 11. Now let's work off this 1 to produce a 0 where we have this value of 3. So let's multiply that first equation through by a -3 and add it to the second equation, or the second line, you might think. So -3 plus 3 is 0. -3 times +3 is a -9, plus 7 is a -2. -6 plus 4 is a -2. And a -33 plus 23 is a -10. This row came from a -3, row 1, plus row 2. Now let's clean up row 3. We want a 0 here where that 5 is. So let's multiply row 1 through by -5 and add it to row 3. -5 plus that 5 is 0. -5 times 3 is a -15 plus 3, or a -12. -5 times 2 is a -10 and a -5, or a -15. -55 and a -14 is a -69. That came from -5 times row 1 plus row 3. Now we'll go to our third augmented matrix. Here we'll begin to work on our second column. We'd like to see the number 1 on the diagonal. So let's take care of that first by multiplying row 2 through by the reciprocal of -2, which is a -1/2. -1/2 times 0 is 0. -1/2 times a -2 is 1. -1/2 times -2 again, that's 1. And -1/2 times a -10 is 5. Leaving a note, that was a -1/2 times row 2. I'm just going to recopy the other rows at this point. So 1, 3, 2, and 11. 0, -12, -15, and a -69. Now continuing with this second column, we'd like to see a 0 right here where the -12 is. We're going to work off this 1 in the second row. So transitioning now to our next matrix, I'm going to just rewrite that second row, 0, 1, 1, and 5. Just going to rewrite the first row. It's okay. 1, 3, 2, 11. Now let's work off of this 1. So I'm going to multiply row 2 through by a +12 and add that to row 3. So we can produce a 0 right here. 12 times 0 is 0, plus 0 is 0. That doesn't affect column 1. 12 times 1 is 12, plus a -12 is 0. 12 times 1 is 12, and a -15 is a -3. 12 times 5 is 60, plus a -69, that gives a -9. That came from 12 times row 2 plus row 3. Now as the last step here, Our last augmented matrix. Things are looking pretty good. Our first two rows are fine. Let's just copy those. We have a 1, 3, 2, 11, a 0, 1, 1, and 5. Last step, we'd like to see a 1 here on our diagonal. So let's multiply at row 3 through by a negative 1/3. Negative 1/3 times 0 is 0, times 0 again is 0. Negative 1/3 times a negative 3 is a positive 1, and negative 1/3 times a negative 9 is a positive 3. So we have this matrix now in row echelon form with 1s on the diagonal, 0s below those. So let's take this matrix now and reproduce equations from it. This first line, as we write it now back in equation form, becomes x plus 3y plus 2z is equal to 11. Our next equation is y plus z equal 5. Our third equation, that's a z is equal to 3. So from our row echelon form then, we have a system of equations where one of the variables is already solved for. We know z. We can use equation 2 to solve for y, because y plus z, or y plus 3, is equal to 5. So y is equal to 2. Lastly, let's use that first equation now to solve for x. X plus 3 times y, or 3 times 2, plus 2 times z, which is 3, is equal to 11. That's x plus 6 is 11, or x plus 12 is 11, so x is negative 1. Let's then describe that answer by saying the solution set is x equal negative 1, y is equal to 2, z is equal to 3. It's wise, students, to go ahead and check those solutions in your original equations, and a check does verify that we have the correct solution.